Hello, in this lecture we are going to learn how to perform the chi-square test for goodness of fit. This test is used when our variable is nominal with 3 or more categories, and it compares an observed distribution with a theoretical distribution. For this example, I will use the categorical variable education level in this data frame, demo. It has 5 categories. And first of all, I'm going to generate a counts table for this variable using the function table. And I'm going to name this table my table. That's it. So we have the counts for each educational level here. And now I'm going to run the chi-square test with equal theoretical probabilities first. I'm going to compute the number of columns of the table with the function length and store it in a variable n. The value of n is of course 5. We have 5 columns in the table because the variable has 5 levels. And now I'm going to store the theoretical proportion in a new variable, this one, and they will be computed as 1 divided by the number of columns in the table. So the theoretical proportion will be equal to 0.20, of course, 1 divided to 5. So we are going to have 5 theoretical probabilities, or all of them equal to 0.20. Now let's run the chi-square test with this function, chi-square.test. We have to specify the table, my table in this case, and then we have to specify the proportion, the theoretical probabilities, with the option P. And here we are going to use the repeat function. Why? Because we want that the theoretical proportions, the variable thprop, to be repeated n times, 5 times. Okay. So let's clear the console first and then run the chi-square t-test with these options, with these arguments. Okay. So the interpretation is very simple. The chi-square value is 71.52 with 4 degrees of freedom, and the p-value is very, very low. It is lower than 5%. So we are going to reject the null hypothesis and say that the educational levels do not have an equal distribution. So the observed probabilities are not equal with the theoretical probabilities. In order to get the expected values, the residual values, and the standardized residual values, we are going to use these values, expected residuals and STD residuals, after the function chi-square test, separated by a $, as you can see here. I'm going to clear the console first. Now let's get the expected values, the expected counts. Here they are. Let's compute the residual values, the differences between the observed values and the expected values. Here they are. And now let's compute the standardized residuals. Here they are in this table. Now let's run the chi-square test for the same variable, education level, with unequal theoretical probabilities. Let's suppose that my theoretical probabilities are as follows: 30%, 30%, 20%, 10%, and 10%. Of course, their sum must be 100%. So I'm going to enter these values in the P option, simply using the C function, the concatenate function. let's clear the console and run this. So the chi-square test value is 111.07 with 4 degrees of freedom. The p-value is lower than 5%. So again, we reject the null hypothesis and say that the observed proportions are not equal with the theoretical or expected proportions. Again, if you want to get the expected counts with these probabilities, with these theoretical probabilities in this case, you use this value expected, and here they are, the expected counts in this table. Now, if some expected counts are lower than 5, you can ask the program to simulate the p-value. How? By using this option, simulate p-value equal to true. So I'm going to run the chi-square test again with equal probabilities. So again, using the repeat function here, and with this option, simulate p-value equal to true. You probably noticed that the execution took a longer time now because of the simulation. So it said that the chi-square test for given probabilities was executed with simulated p-value based on 2000 replicates. Again, the p-value of the chi-square test is much lower than 5%. So again, the conclusion is the same. The observed counts are not equal to the expected counts. That's all. Thank you.